Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook, this one tiny mistake cost more students marks than almost any other question on last year's exam. They forgot to flip the inequality sign when they multiplied or divided by a negative number. It sounds small, but that's often the difference between a 6 and an 8. Stay with me. By the end of this episode, you'll have a simple routine that prevents that slip every time.
The concept. Starting simple. What is an inequality? It's a statement that one quantity is larger or smaller than another. For example, x less than 3 means x can be any number less than 3. Unlike an equation, you usually get a range of answers, not a single number. Let's solve a linear example together and explain why each step works.
Example 1. Solve 3x minus 5 greater than 1. First, isolate x. Add 5 to both sides to get 3x greater than 6, then divide by 3 to get x greater than 2. That's it. Write the final answer as x greater than 2, and, if asked, show it on a number line with an open circle at 2 and an arrow to the right. That open circle shows the boundary is not included.
Now, the tricky rule students forget. If you multiply or divide both sides by a negative number, you must flip the inequality sign. Why? Because multiplying by a negative reverses the order on the number line. For instance, 2 is greater than 1, but minus 4 is less than minus 2. The negative multiplies change positions. Example 2. Solve minus 2x plus 4 less than or equal to 8. Step 1. Subtract 4. Minus 2x less than or equal to 4. Step 2. Divide by minus 2. Divide and flip the sign, x greater than or equal to minus 2. Note the inequality flipped from less than or equal to greater than or equal to because we divided by a negative. Write that flip in your working. Examiners look for it.
Open versus closed boundaries, quick note. Use an open circle for less than or greater than, and a closed filled circle for less than or equal to or greater than or equal to. In interval notation, that translates to round brackets for open, square brackets for closed. X greater than 2 becomes 2 to infinity, and x greater than or equal to minus 2 becomes minus 2 to infinity. Little notation slips here often cost marks.
Compound inequalities are next. You might see something like 1 is less than 2x plus 3 less than or equal to 7. Treat this as two linked inequalities. First, 1 is less than 2x plus 3, and second, 2x plus 3 less than or equal to 7. Solve each side, then combine the result into a single chained statement. A clear step-by-step write-up prevents careless algebraic errors.
Moving to quadratics, still the same idea, but use factorization and sign analysis. For a quadratic inequality, like x minus 2 times x plus 3 less than 0, find the critical points, x equals 2 and x equals minus 3. These split the number line into 3 intervals. Test each interval with a simple value to see whether the product is negative or positive. This method is robust and quick once you get used to it.
Exam technique. What the examiner actually wants. For a typical 3-mark inequalities question, the breakdown looks like this. M1 for a correct method step, such as isolating the variable or factorizing a quadratic. M1 for a correct follow-through, such as solving the resulting simple inequality or showing correct interval signs. And A1 for the final correct answer in the requested form. Write down every algebraic step clearly. That gives you the best chance of collecting method marks, even if the final arithmetic slips.
Common notation errors to avoid. Using the wrong bracket type in interval notation, forgetting to flip the sign after dividing by a negative, and not labeling open versus closed boundaries on a number line. Also, if you factor a quadratic, show the factorization. That single line often earns an M1 even before you test intervals. If you can't finish, still write what you can. For example, show your factorization or your isolated inequality. Examiners award method marks for correct intermediate work, so write it down, don't just think it. That's where marks are for the taking. The quick win, a simple routine you can use on every inequality. Isolate, simplify, flip check. I call it flip check. First, isolate the variable terms. Second, simplify step by step and factor if needed. Third, if you multiply or divide by a negative, flip the sign. Then check your final answer by substituting one test number from your solution range back into the original inequality. That last check takes 10 to 20 seconds and catches the majority of careless slips. Nail that routine and you'll stop losing easy marks.
Now a worked example and live check. Solve x minus 2 x plus 3 less than 0 and show exactly what to write for marks. Step 1. Factor is already given. State the critical points x equals 2 and x equals minus 3. Step 2. Draw a sign table or mark the number line with minus 3 and 2, splitting into minus infinity minus 3, minus 3 2, and 2 infinity. Step 3. Pick a test point in each interval. For minus infinity minus 3, pick minus 4. Compute minus 4 minus 2 minus 4 plus 3 equals minus 6 minus 1 equals 6, which is positive, so inequality false there. For minus 3 2, pick 0. Compute 0 minus 2, 0 plus 3 equals minus 2 times 3 equals minus 6, which is negative, so inequality true there. For 2 infinity, pick 3. Compute 3 minus 2, 3 plus 3 equals 1 times 6 equals 6, positive, false. Conclude the solution is minus 3 less than x less than 2, written as minus 3 2. Make sure you show the test calculations. Each one is clear evidence for M1, and the final interval is the A1.
Live check. Substitute x equals 0 into the original inequality x minus 2 x plus 3 less than 0 and show minus 6 less than 0. True. That final substitution confirms your interval and is a tiny habit that saves marks under pressure. Don't skip the check. Quick checklist to copy into your exercise book. 1. Isolate and simplify. 2. Flip the sign if you multiply or divide by a negative. 3. Show factorization if present. 4. Mark open-closed boundaries and write interval notation. 5. Substitute one test value to check. Keep this handy during revision.
Final recap in one sentence. When solving inequalities, isolate, simplify, remember to flip the sign with negatives and always test your answer. That's your exam-ready routine. That's your quick win for today.
If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable checklist at jcacademyonline.co.uk. Visit the site for a pack of practice questions that follow exactly the routines we use here. Until next time, trust the process and nail that exam. Stay curious.